Hello, welcome to part 3 of C++ programming in Android. We have been writing simple C++ programs in the mobile C programming environment. It's a free app in Android that works really nicely, very easy to use. And so we've written programs which print out things that we've programmed, and we've printed out programs that printed out a variable. We've also created the ability of the computer to solicit input and store that input in a variable, do something with it. We added it and then we spit it back out again as a sum. And today we're going to learn more variables. We have a lot of variables in C for different types of things, letters, numbers, different precise values, etc. So we're going to do more variable types, and we're also going to learn to list values or variables. They have each value as a designation, so each value, I suppose, is a variable inside one larger variable. And we'll learn how to access individual members of a larger group of variables precisely. Little housekeeping first. Since we're using more tools here, we need to add a new preprocessor directive. It's called vector, because one of the things we're doing is storing information in a group variable called a vector, which will hold a number of values inside it. Vector is not used in the most basic toolkits of C++, so we have to use the preprocessor directive to instruct the computer use that toolkit. Otherwise the computer won't understand what the vector is. So you just type that in under include IOStream. We're using the same namespace standard. And again, these are kind of just like addressing the envelope. You don't really need to know how they work right now. You just need to know that they have to be there. And of course, using namespace standard has to end with a semicolon. We're going to learn about comments. You've seen the things in green. Comments are words, language that you add to the program that doesn't affect how the program runs, but it tells the program, tells the person who reads the programming special information. Like you might want to explain what you're doing, or what needs to still be done, or ask, leave a special explanation. Because you'll forget what you're doing, and a comment, if something doesn't look right, a comment might make things clearer to use. Again, if a comment is between to the right of 2 forward slashes, computer won't see it. And it'll appear in green in our mobile C environment, which is extra useful because the stuff in green is not going to affect the computer or how it runs. But if you leave one of those slashes off, the computer will crash because it won't know what these weird words are stuck in the middle of the code. So the stuff in green is comments. They make it easier for you to see how the programming is arranged. And you can write anything in the comments and just keep them to the right of the rest of the programming. And they're very useful because programming involves a lot of customization, and you need to explain why you customize something. Because professional programmers spend a lot of their time, most of their time, maintaining other people's code, updating it, changing it, adjusting it, and the more comments they have, the easier it is. Okay, so let's go to the new different types of variables. We have the integer, which we've already used, a number without a decimal place, between 64,000 and negative 64,000, approximately, and that's very useful for keeping track of a large number of items. But not necessarily useful for really high-level math, but we'll use other variables for that. We have character, which is letter, a single letter, or it could be a number, but it will be treated as a character. If you declare a character with the value with and assign a 4 to it, you can't add that character to another character. Float is decimal places. Float will allow you to add and subtract and multiply and divide large decimal place numbers, because if you divide integers, it will round up, and that's not very useful. So here are our three: Snoopy, Woodstock, and Linus. Snoopy is a 4 integer. Character, Woodstock, and float, Linus. Now what I'm doing here is I'm declaring the variables, but I'm not assigning them a value yet. You can do that. You might not know what the value is until later, so you assign the name first. And then double is a highly precise float, double precision. And a Boolean variable is a yes or no only. It's stored as a 0 or a 1. It's also referred to as a true or a false. This is a very useful variable type. When you will be using conditional language to evaluate the truth or falsity of an expression, and the result of evaluation will be either a 0 for false or a 1 for true. You'll ask, is variable Snoopy less than 3? If you ask that in a certain way, the answer will be expressed as yes or no, 0 or 1. So Booleans are very useful. Okay, we also have double precision there. So as you can see, I've made both of those. I've made double very long, and the Boolean violet I've assigned true. I could also assign 1, but remember, there's only 2 values to a Boolean. Okay, and remember, we did not assign values upon declaration for Woodstock or Linus. We don't have to. We'll do them later. The reason is because the existence of the variable is necessary for the computer to function, perhaps, but we don't know the value yet. Okay, we also have a constant type qualifier. Constant is not a variable type. Constant is a characteristic of different types of variables. The thing is, they're not variables, they're constants, i.e. Integer constant will not change throughout the entire program. That's very useful. You add const before the numerical type, before the const int, and that prevents the computer from ever changing that value. That can be extremely useful, because especially when you're working with some data, certain numbers don't change, and so you run the risk of making, if you make it as a regular variable, you might accidentally change it with a logic somewhere in the computer by mistake, and the computer will not allow you to change the value of a constant. So it's a way to organize your data much more carefully. So let's print out our new variables. Like I said, we're assigning some values to variables later. Don't have to assign them at the beginning. And floats and doubles will have decimal point precision. So what I've done, we're getting to the point of the program where we're printing out the variables we've declared, and with Woodstock and Linus, I'm just printing out the variables. I'm assigning the variable values right before I print them out. You can do that. You'll notice Woodstock character that's a letter, those are declared with a single quote. Woodstock's value is G. Okay, you'll notice Linus has a lot of decimal points after it. Those won't all be preserved. And we also assigned Patty a large value. We'll look at that, a very precise value as well. And we'll see how much of that survives the printout, the read. We'll see how much of that value survives when we call it back from memory. Yes, so here we printed it out. Linus's float was cut back substantially. We cut five or six places off the end of it. That was, it's still pretty precise, but it's not as precise as it was when we declared it. But it's much better than an integer, and when you add or subtract it by another float, the precision is preserved, unlike an integer. And notice Violet's Boolean prints out as 1. We declared it as true, but it printed out as 1. So let's look at this for a minute. You'll see Woodstock was G, and it came out as G. Notice it was between single quotes, and those are not reproduced. There's not an enormous value to preserving individual characters as variables, but later they will be arrayed together in groups of letters, and you spell out a word. That's very useful. Okay. And one little note, you do not have to assign a value to every variable and constant you create, but if you do not declare the constants, you'll get an error if you try to assign a value to a variable or constant that you did not initially declare. You'll notice the variable Patty had 10 decimal places, but it only printed out 5. So it's kind of the same as Linus, but it's double precision. Now you have arrays and vectors. These are groups of values grouped in one larger value. The idea of variables was to assign a variable to a name. Now we can assign a number of values to one name. This is an array. Charlie Brown is an array, and we've declared it's an int. It's an integer array. 3 integers inside the little brackets separated by columns. Charlie Brown followed by the 3 in brackets tells us we have 3 integers in one name, associated with one name. That's nice, but how do you specify each individual value of Charlie Brown? You do that by referring to the index number. That's the place within the brackets. In this case, you'll notice first is 0, the second is 1, the third is 2. It's important to remember that the index values start at 0. That's kind of like when you do math and you have n as n as the index value for a group of numbers. N always starts at 0. So we will refer to the numeral 4 as Charlie Brown element number 0. And that's very useful because you can store a whole bunch of things under one name, Charlie Brown, or you just say the 4th element of Charlie Brown, and you know exactly what it is. Vectors are an assortment of values as well. However, vectors can change size. This is how a vector declaration looks. And you can also use characters for vectors. Vectors are not necessarily used very much in elementary stuff, but they're very much like arrays. This vector has 4 members. Each member is t in this instance because that's just simpler. But vectors will have the ability to add an additional member to it, not just change the values. Okay, so let's print out. We declared Charlie Brown and we declared Marcy. Charlie Brown, the array, has three values, and I made an error here. And so it's a nice instructive error, and so I left it in. Charlie Brown has 3 members. The first one has the index number 0. The second one has the index number 1, and the third one, the numeral 11, has index number 2. And I told the computer to print out Charlie Brown 3, Charlie Brown bracket 3. You'll see right there. However, that would be the 4th element of Charlie Brown, and Charlie Brown only has 3 elements. So if you look below, it printed out a 0. Meaning it failed to find anything. Now, that's a slight flaw in how C works, because if Charlie Brown was a 4 element array and the fourth element with the index value 3 was a 0, then that would print out the same information. It would be nice if it printed out not a number or failure or something in this case, or null, but it didn't. So it's a thing you have to be careful of. You have to be aware of some of these flaws, and they're not flaws; they're flaws in how the program was constructed by me. But ideally, if I had typed in Charlie Brown, print out Charlie Brown brackets 2, that would have printed out 11. Okay, and I also instructed the computer to print out the second element of the vector Marcy. Since all the elements are t, it prints out a t. Another way to group data is an enum. Now we have 4 names here in this enum. They're all in brackets separated by commas, and the enum's name is Peanuts. Now, this is a little more complex because Sherman, I've told the computer to print out the variable name Sherman, and it prints out a 2. It prints out a 2 because that's the index value of Sherman. It's kind of the opposite of an array, where you enter the array number and it prints out the name associated with that place. Here you enter the name and it prints out the index number associated with that name. It's not quite as useful at first glance. It's very useful later on. Once you start, you'll ask the computer, what place is Sherman online? Starting with 0, Sherman is 3rd online. And later on, that will be very useful and productive. It's not quite as intuitive as an array, though, where you ask it to print out the 3rd person, it prints out the name Violet. That's great. And the enum, just like the array and the vector, you use an index value. And of course, the index value always begins with 0. It's easy to drop that ball, as you saw when I made that error 2 slides back. So thank you. I hope I didn't go too quick this time. We were just working on new variable types and group variable types, and I showed you how to do comments. Um, this is you have to know all these different types of values because types of variables because you're going to be sometimes dealing with text, sometimes with numbers, sometimes you're going to be performing precise mathematical calculations with and you're going to need um, real precision, decimal precision. And I appreciate your listening, and I hope I didn't go too fast. Leave notes in the comments, and we hope you enjoyed and learned something. Have a good night.